All right, we're going to be solving story problems. One of the first things you're going to do when you approach a story problem is to read that problem twice. The first time is just to get a sense of what is going on in the problem, and the second time you're going to start figuring things out. And the second time you go through it, find the verb, or I should say maybe the verbal phrase, because that will give you the equal sign, which you're going to need when you write an equation. A number decreased by 23 is equal to negative 19. A number decreased by 23, well, is equal to is obviously going to be your equal sign. Whatever comes before that is going to be before the equal sign. Whatever comes after is going to be after the equal sign. So something's going to be equal to negative 19. Well, what we need to do is translate this phrase, a number decreased by 23, into an algebraic phrase. Well, a number is going to be the variable you choose, so I'll choose x. Decreased by obviously means minus sign, 23, and we now have an equation, x minus 23 is equal to negative 19. To solve this equation, we're going to add 23 to both sides, and we get x is equal to 4, your final answer. Next, we have 4/3 of a number is the same as 160. 4/3 of a number is the same as, obviously, there's your equal sign. Something's going to be the same as equal to 160. Well, of means times. So we're going to take 4/3 times a number times x, and we're going to get 160. To solve this particular equation, we're going to multiply both sides by 3/4, and we get x equals 120. Next, we have twice the sum of a number and 4 is 12. Twice the sum of a number and 4 is 12. Well, obviously your is going to be the equal sign, so something's equal to 12. I underlined the sum of because that's a very special case where the sum of means whatever comes after that we put in parentheses. So the sum of a number and 4 would be n plus 4 in parentheses. Twice that means we take 2 times that quantity, n plus 4 equals 12. To solve, use the distributive property. We have 2n plus 8 is equal to 12. Subtracting 8 from both sides, we get 2n is equal to 4. Dividing both sides by 2, we get n equals 2. Final answer. Now we're going to have all kinds of story problems that we're going to have to be solving. Some of them deal with age, some of them perimeter of a rectangle, some of them we're talking about marbles. We're talking about, the number of coins. And then there's also consecutive integers. Consecutive integers, consecutive evens, and consecutive odds. Well, integers are those numbers you normally think of when you picture a number line in your head. So now pictured here is the typical number line, and these are your integers, 0, 1, 2, 3, 4, 5, 6, and so on, -1, -2, -3, and so on. Those are the integers that we're going to be talking about. Well, consecutive integers would be those integers that are in a row next to each other. For example, if one integer was 14, my second integer, how would I find that? By taking 14 and adding 1 to get 15, and 14 plus 2 to get 16. So my three integers would be 14, 15, and 16. Well, let's say we don't know what our first integer is. It's some arbitrary integer somewhere on the number line. We just know it's an integer. Let's call it x. No matter what it is, in order to get to the next one, I have to add 1 to it. And to get to the one after that, I'm going to be adding 2. So x would be the first integer. x plus 1 would be the second, and x plus 2 would be the third. This is how we're going to set up consecutive integer problems. Then we have consecutive even integers. For example, I might have 22 being my first integer of any three consecutive evens. What would be the next one? Well, it's 24. How did I get there? I took 22 and added 2. And to get to the one after that, I would take 22 and add 4, right? And get 26. Well, let's say I don't know what that first even integer is, but I do know it's even. No matter where it is on the number line, if I have some arbitrary integer x, in order to get to the next one, I would have to add 2 to it, and to the one after that, I would have to add 4. And this is how we're going to set up our consecutive even integers. The next thing we would be talking about is consecutive odd integers. Consecutive odd integers might be something like if we had 39. Well, what would be the next one? Well, it would be 41. Well, how did we get there? We took 39 and added 2 because consecutive odds are 2 numbers apart. So if my first one is 39, my second one would be 39 plus 2, and the next one after that would be 39 plus 4 and getting 43. Well, again, if I didn't know what the first one was, okay, so let's just say any arbitrary odd integer, and keeping in mind that it is an odd integer already, let's call it x. That's our first one. Well, no matter what it is, since it's already odd, to get to the next odd one, we have to add 2 to it. And the one after that, we would add 4, and this is how we would set up consecutive odd integers. Well, in solving a story problem like number 1 here on the next page, the first thing you want to do in solving a story problem is defining a variable. What that means is we're going to pick a variable and we're going to tell exactly what it stands for. So in defining a variable for 3 consecutive integers whose sum is 291, as we pointed out earlier, what we're going to do is we're going to say let x represent the first of my 3 consecutive integers. Since we're talking about consecutive integers, the next one after x would be x plus 1. That would be our second. And the one after that would be x plus 2 is the third. Well, we want the sum of these things to be 291. So in essence, what we're saying is that if I took the first integer plus the second integer and then plus the third integer, I'd get a total of 291. Well, what are we calling the first integer? Well, it's called x. Plus, what are we calling the second integer? Well, we're calling it x plus 1. And then we add that to what we're calling the third one, and we're calling the third one x plus 2. And all of that is equal to 291. Well, this is an equation we know how to solve. All we have to do is combine like terms. X plus x plus x is 3x. 1 plus 2 is plus 3 equals 291. And subtracting 3 from both sides, we get 3x is equal to 288. And when I take 3x equals 288 and divide both sides by 3, we get 288 divided by 3 is 96. So x being 96, that's our first integer. So our first is 96. The second one would be one more than that, which is 97. And the third integer would be one more than that. 96 plus 2 is 98. You always want to make sure that they do fit the story problem, being the sum is 291. Do they add up to 291? Yes, they do. And there are our answers. In number 2, we're going to find 3 consecutive even integers. Now here we're talking about even integers whose sum is 90. Well, we always start out with a consecutive integer problem, regardless if it's consecutive integers, consecutive evens, or consecutive odds. We always start with let x equal the first one. That is always going to be the case for consecutive integer problems. Well, since we're talking about consecutive evens, then we would have to add 2 in order to get to the second integer, and we would have to add 4 in order to get to the third. Well, it says their sum is 90, so we add these three things up. X plus 2 plus x plus 4 equals 90. And yet here again is another equation we know how to solve. Combining like terms, we get 3x plus 6 equals 90. Subtracting 6 from both sides, we get 3x is equal to 84. Dividing both sides by 3, x is equal to 28. So if our first integer is 28, let's say I made a mistake and forgot what I was doing, and I just said the second one was 29 and the third one was 30. You still want to check to make sure that these things add up to 90. Well, here in this case, with these, they would only add up to 87. So somewhere we made a mistake. So we'd have to go back and verify everything that we did. I solved the equation correctly, but I forgot that we had to add 2 because we're talking about consecutive evens. So my second one would be 2 more than this one. 28 is 30. 2 more than that would be 32. When I add those up, I get 90, and I have the correct answer. Now I'm looking at consecutive odds, and just like before, with all consecutive integer problems, I'm going to let x equal the first. It represents the first of my 3 odd integers. Now, keeping in mind that these are odd, x is already an odd number. In order to get to the second one, I still have to add 2, and to get to the one after that, I have to add 4. The sum of these is 39, so x being my first, plus x plus 2 being the second, plus x plus 4, my third, is 39. Combining like terms, 3x plus 6 equals 39. Subtracting 6 from both sides, I get 3x is equal to 33. Dividing both sides by 3, I get x is equal to 11. So if my first number, being x, is 11, my second would be 2 more than that, 13, and my third would be x plus 4, which is 15. Do these add up to 39? Yes, they do. The next kind of problem we're going to be working on is a perimeter problem. Well, the length of a rectangle is 100 inches more than the width. If the perimeter of the rectangle is 1,320 inches, find the dimensions. Well, by dimensions, we mean the length and the width. We'll circle those words, length and width. Now, when here, from now on, with anything other than consecutive integer problems, whenever you go to define the variable, you're always going to want to go with the second one mentioned. Doesn't matter how many unknowns there are, always go with the second one mentioned. So width being mentioned second, I'm going to say let W equal the width. Now that I have something for the width, I need a mathematical phrase that will be what we'll use for the length. Now, what does it say about the length of our rectangle? The length of the rectangle is the length equals 100 inches more than the width. Well, what's our width? What are we calling it? W. What's 100 inches more than that? W plus 100. So we're going to be using W for the width and W plus 100 for the length. Perimeter, we'll use our formula, and I like to write it out in words. 2 times the length plus 2 times the width equals P. This is the formula we're going to be using for perimeter. I'm going to use for the length here, I'm going to use W plus 100. So this is what I'm going to put in for the parentheses for the word length. And then I'm going to put in parentheses W for the width. And my perimeter is 1,320 inches. To solve this equation, we'll use the distributive property, 2W plus 200 plus 2W is equal to 1,320. Combining like terms, 2W plus 2W is 4W, plus 200 equals 1,320. If 4W plus 200 is equal to 1,320, to solve this, I'll subtract 200 from both sides. I get 4W is equal to 1120. Dividing both sides by 4, I get W is equal to 280. Well, what does that mean? Well, it means that since in the very beginning we said that W was the width, it must mean that the width is 280. How do you find the length? Add 100 and you get 380. We always want to make sure that things work out in a story problem. So add those two things together, you get 660. And because we have to multiply it by 2, we get 1,320, and it does check out. Number 5, the perimeter of a rectangle is 222 feet. If the length of it is 3 less than twice the width, find the dimensions of the rectangle. Well, the perimeter is 222. Here's the length. Here's the width. Which one's mentioned second? The width. So I'm going to say let W be the width. Now I'm not going to be able to use L for the length. I have to write an algebraic phrase. It's called an open phrase for what we're going to be using for the length. And now what does it say about the length? The length is, well, it's 3 less than twice the width. And we've been working up to this point on translating verbal phrases into algebraic phrases. And how do we do that? Well, my algebra teacher, Jim Myers, always told me to start at the very end and work your way backwards. What are we calling the width? W. What's twice the width? 2W. How would you write 3 less than that? Here's where it gets tricky because 3 less than that has to be minus 3. So we'll now use the formula that we used above, 2 times the length plus 2 times the width equals P. And now we're going to use these things that we've created over here to use in our formula. So I'm going to have 2 times now the length, we're using 2W minus 3. So I'm going to put that in this parentheses. And I'm going to use W for the width. And my perimeter is 222. Well, I know how to solve this equation. Use the distributive property, 4W minus 6 plus 2W is equal to 222. 4W plus 2W is 6W minus 6 equals 222. Adding 6 to both sides, I get 6W is 228. And when I divide both sides by 6, I get W is equal to 38. So W being 38, that must be the width, because I said from the beginning that W stood for the width. Well, to find the length, what I'll need to do is take 2 times W. So 2 times 38 is 76. Subtract 3, and I get 73. Now, do these two dimensions give you a rectangle with a perimeter of 222? Well, when we add these up, 38 and 73 are 111, times 2 is 222, so it also checks out. The next type of problem we're going to be solving is final cost problems. Now, a tax is a percent of the cost added to that cost. And the operative word here is added to. A discount, on the other hand, is a percent of the cost subtracted from. Now, I'm going to show you two ways to solve a final cost problem. And the first way is to figure out 15% of $16, and then because it's a discount, we'll subtract it from. Well, 15% of 16 would be computed by moving the decimal point in our percent 2 places to the left. So I get 0.15. Of means times 16. So 15% of 16 would be $2.40. What we'll do is subtract that from the $16, and we get $13.60 for the final cost. On the other hand, if you wanted to take a shortcut, we could also look at that 28%. And that's what's discounted from 100%. Well, 100% minus the 28% would be 72%. So we could just take that times 28. And that would give us the final cost. So if you took 0.72 times 28, you'd get $20.16, your final cost. 33%, well, 100 minus 33 is 67. So we're actually paying 67% of the 248. So we could take 0.67 times 248, and that would give us our final cost. So 0.67 times 248 is $166.16. That would be the final cost after the discount. Now, sales tax is added back on to the final price. So our sales tax of 4% will be added on to the 24. How do we compute that? Well, we're going to take 4% of $24. Move the decimal point twice to the left, and we get 0.04 times 24 is 96 cents. That's the amount of our sales tax. We add that on to the 24, and we get $24.96 being the final cost. On the other hand, if we're paying 100% of the $4.99 for this computer, and then sales tax is 5.5%, what we'll actually end up paying is 105.5%. Take that times your $4.99, move the decimal point twice to the left, and take $4.99 times 1.055, and we get $526.445. But since we have to round this off to the nearest penny, it would be $526.45. We're paying $10.95 for a calendar. With sales tax, that would be 1.09 times 10.95. So 1.09 times 10.95 would be what? Plugging that into your calculator, you'll get 11.9355. Again, we're rounding off to the nearest penny, so that would be 11.94. So the proper way to find discounts and sales tax would be to find the actual discount and sales tax. A shortcut would be to just multiply times the decimal. To find the discount and sales tax, keep in mind that discounts are computed first, sales tax are computed second. For a ring costing $89 with a 17% discount, 100 minus 17 is 83, so we'd actually be paying 83% of the $89. So 0.83 times 89 is 73.87. Take that times 1.05 because of the sales tax, and we'll get 77.5635. Rounding it off to the nearest penny, we're actually going to be paying $77.56. 100 minus 21 is 79%. So we're going to be paying 79% of the $44. So 0.79 times 44 is equal to 34.76. We're going to take that times 1.06, and we'll get 36.8456. Being that this digit is from 5 to 9, we have to round this digit up, so it'll be 36.85. We're actually going to be paying 80% of this Blu-ray DVD player, so 80% of 275. So I'm going to take 275 times 0.80. That's $220. Adding the sales tax, I'm going to be taking that times 1.07. And I get $235.40. And that's what we would be paying for this DVD player, this Blu-ray DVD player, that was originally costing $275 with a 20% discount and sales tax of 7%. And lastly, for a coat being on sale for 25% off the original price, so I'm going to take 25% from 100. So we're actually going to be paying 75% of the price of $75. So what's 0.75 times 75? We would get 56.25. Then I'm going to take that times 1.0925, and I'll get the decimal 61.453125. Rounding it off to the nearest penny, 61.45 would be my final answer.